Mercedes-Benz announced the new S-Class, and they also announced that it features an option that is wireless charging. So also they mention there is no cables to manage, no plugs to plug in your car. Just park it and charge it. It's very convenient. Again, a few months later, the BMW i3. It got wireless charging, but actually it didn't get it from BMW. This was from Plugless Power. It is an add-on package that you can purchase, and you can add it to your BMW i3. And it also allows wireless charging. So it's really coming up. So you might think that this is really new technology, but I'm not sure if people recognize this tower. Yeah? It's actually the Tesla tower. It's from 1904. It's 1904, so it's more than 100 years old. And it was intended for wireless power transfer. And actually, Nikola Tesla thought that he could really power the whole world using this tower wirelessly. I think it's a bit too ambitious, but still, what is very nice is that his initial papers, also from the 1900s, actually describe the system that we use today. So if you think it's new, it's not. It's just more than 100 years old technology. What we do is we add smart control, and we add some flexibility to the circuits to be able to control it in a better way. And here you can also see it's not too difficult. This is a student project. We have a bachelor's program, and this is an OGO project. And more than 10 groups of students built these kind of wireless charging systems. And to my surprise, this one worked. And it was able to transfer 100 watts of power over 10 centimeters of distance. So this is a transmitter and the receiver, and there's 10 centimeters in between. With wireless charging, it comes with some questions. For instance, would you like to put your hand in between those two coils? Would it be safe? And I will come to this. But first, let's start with some short market analysis. Research shows that, we've seen it also today, that autonomous vehicles will have an increasing market share. You can also see it at the moment. Tesla is becoming a market leader in this. And in 2035, it is predicted that 25% of the market share of the new cars is an autonomous vehicle. And this means that the total market for autonomous vehicles is over $77 billion US. So this is a lot of money. So what is wireless charging? What is the role of wireless charging in this? Well, who will plug in your autonomous vehicle? So it's not the taxi driver. The vehicle itself has to do this. And the easiest way to do this is obviously wireless charging. So, and what's more is that I believe that wireless charging also promotes the adoption of regular EVs. You never have to plug in anything. You never have to refuel. So I think that wireless charging really is essential for future automotive industry. And you can also see that it's really a booming technology. If you look on the number of papers per year, so this is the yearly number of papers on the subject. Yeah, you can see that around the introduction of the Tesla Roadster and the Nissan Leaf, there is really booming business in wireless charging. However, wireless charging comes with some drawbacks. This graph, it's rather complicated, but actually this part shows conductive charging and some performance figures, and the other ones are inductive power transfer charges. And what you can see is that the efficiency, that's this bar, of a conductive charger, it's around 95%. So 95% of the energy you put in actually goes to the battery of your vehicle. If you use wireless charging, it's around 90, and the best systems go a little bit higher, but generally around 92%. In terms of volume that you need for the same amount of power, you can see that you need 1 liter for 5 kilowatts of power for a conductive charger. While with wireless charging you have roughly 2.5 kilowatts per liter. So you need more volume and you have twice the losses. So it's really a compromise, wireless charging. And you trade off volume against efficiency. Well, this is a graph. I've actually seen it outside this lecture room as well. And this is generally how they picture wireless charging. You have a wall box, and in the wall box is the mains interface with a PFC and an inverter that generates high frequency voltages for the transmitter coil. There is electromagnetic fields that are received by a resonant receiver, and that is connected to a rectifier module with communication interface. Eventually this energy flows into the battery. And you can see this it's a bit dark here, but you can see here a practical example. This is with the BMW i8, and you can see the ground pad. Underneath the car is of course the receiver module. There is an infrared cable between the ground pad and the wall box, and eventually there is a mains connection. And you can see that these systems still are in development. This is not a final product. And this is based on the Qualcomm Halo system. That's one of the few systems available at the moment. And it's a license-based technology. So if you want to use this, you have to buy their licenses, but you have to produce it yourself. So another interesting feature about wireless charging is that the efficiency depends on a lot of things. And one of these things is the distance between the transmitter and the receiver, so the range that you need. And what you see is that the efficiency is actually quite high for quite a large range of distances. But actually there is one point at which the efficiency drops rapidly. And generally, electric vehicle chargers operate at 10 centimeters air gap. And this means that they're on the top side of the graph. And this is around 95% theoretical limit. So still this is quite good, but the reason that the efficiency in practice is low, I will show later on. And one of these reasons is misalignment. If you look at the efficiency in terms of misalignment, so I'm not very good at parking my car, and I think I will be like way over the graph. And I think most people will be, because the maximum misalignment is 75 millimeters. So you have to park really accurately to achieve high efficiency. And I think the only reason, or the only way to do this, is use automated parking. So automated parking is, in luxury cars, is a common good. And yeah, what you have to do is you have to determine the position of the ground pad, and you have to steer this parking system towards the right direction so that it knows where this ground pad is to steer the car exactly on top of the transmitter. Yeah, there are some methods available. Generally, magnetic vectoring is used. So you determine the direction of the magnetic fields of the transmitter pad, and this is communicated to the automated parking system. And yeah, there is really a lot of gain with correct parking on top of the pad. So, apart from this, there is another challenge. You do not only have to align properly, and you do not only have to have a small air gap. Another thing is that you have to tune the resonance frequencies. It's a resonant system, and it's like having two springs with a mass in between. If the masses are not tuned, you cannot get it to oscillate properly. And if it's aligned, it's like on the left graph. If it's aligned, you get a lot of output power in resonance. But if it's misaligned, so if the resonance frequencies are not exactly equal, then the output drops rapidly. And this is a decibel scale, so it's a large difference. And this is just a mismatch of 5 kilohertz resonance frequency. So what you have to do is you have to match the resonance frequencies on the primary and the secondary side to be able to have sufficient output. And well, the most common method is to use tuned capacitors. So you switch on and off capacitors on the fly on both sides to be able to keep the whole system in tune. And you have to do communication to be able to do this properly. So you need wireless communication that is very fast to be able to tune this on the fly. Yeah. So in principle, wireless charging works. If you do all this, it's perfectly fine. But there are much more issues actually, and these are still open issues in research. We've talked about the positioning, we've talked about matching. Another thing is communication. Wi-Fi, for instance, is not reliable and it has some latency. So how can you get a good loop rate if the latency is too high? Another thing is foreign objects in the air gap. If you drop your wallet while the car is charging and some coins roll over the ground pad, they will glow red hot within a few seconds. Here you can see a key that's laying on the ground pad. It's 90 degrees and this was just within a few seconds. So you need to detect this, and it's very difficult to distinguish between power flowing to the key or power flowing to the battery. Another thing is for living creatures. If your neighbor's cat is crawling underneath your car, you don't want to fry his cat. You also don't want to fry the neighbor that's trying to catch the cat. So, and this is also really difficult. There are systems that are using radar at the moment to trying to detect heartbeats. That's how I did it, trying to detect heartbeat frequencies while charging. But it has to be reliable, and this is very difficult. Sorry?
And fast.
Yeah, and fast, exactly. There are a lot of other issues. You have to be able to drive on top of the ground pad without braking. There are health issues, safety issues, electromagnetic compatibility issues. So the actual system, it's not only this. It's much more than just this simple graph. And this is just a draft of some things that I've touched in this presentation. And you can already see that each of these things are different discipline. It's not only electrical engineering or it's not only power electronics. It's all kinds of disciplines. And this makes the subject really difficult. And I think that's why Tesla initially failed. Because he was just an electrical engineer. We need much more than that. So to design wireless chargers, you really have to think multiphysical. You have to include all kinds of fields of expertise. You have to define multi-objective cost functions because the system highly depends on range, on size, on volume. You have to know what kind of efficiency you want to determine the cost. So the best charger is not the most efficient one, but it's the one that has the best mix of all those properties. And I think that in the Netherlands we can do better than elsewhere if we do proper collaboration. And I think if we collaborate and we can define proper cost functions for these kind of converters that include all domains, we can have a winning solution. So to conclude, wireless energy transfer finally found its use after 100 years. And it is possible. It's not a problem. You can do this. But the power transfer is actually the easy part. You can do it as long as the air gap isn't too large, as long as the position is accurate, and impedance matching is implemented. But we need still a lot of research. But I think it's very significant for the future automobile industry, and it's extremely challenging to do this. Thank you.